This is the only standing pre-World War II blast furnace left in the country, so it's quite unique and quite singular. From the start of the American Revolution, which started approximately the end of the Civil War, until the mid-1980s, this area was the epicenter of the steel industry, not only in the country but in the world. During its heyday, this particular area produced 50% of the steel in the United States and 25% of the steel in the world. There were between 225 and 250,000 people who worked in the mills in this particular valley. Today, there's less than 3,000. Between 1976 and 1986, this area lost 165,000 manufacturing jobs. So this city has totally reinvented itself. What you're seeing today is an iron plant, a blast furnace, which is really a huge smelter. Smelting's been going on for 7,000 or 8,000 years. And really what smelting is you take an ore, you melt it, you remove the impurities, and you cool it to get a higher concentration of the ore you're looking for. In this particular case, iron. They smelt nickel, they smelt copper, they smelt silver. You get the main product you're looking for, which is pig iron. And it was called pig iron because when it sat in the troughs where it cooled, it actually looked like pigs that were weaning from the sow. That's why they called it that. So they made iron here. The iron was sent across the river where it was made into steel. And steel is basically iron without the carbon. It was not economical to manufacture steel until the Bessemer converter was invented in the late 1850s. Once after the Civil War, they were able to manufacture steel, and this is why the steel arrived here. There already was an iron industry in Pittsburgh before the Civil War, and this seemed like an ideal place to do it for a number of reasons. One was water. Every major steel mill is located in a body of water. These two furnaces you're going to see today use 5 million gallons of water a day to cool them. So you need a tremendous amount of water. So you'll never see a steel mill that is not next to either a river or a lake. Second reason was the availability of raw materials. The iron ore came from Minnesota, but Western Pennsylvania had a special type of coal that was very good for the manufacture of coke, which was the fuel that's used in the blast furnace process. Now, in the blast furnace process, there's 3 main components. First, of course, is iron. This is iron ore. This comes from Minnesota. It's called taconite. It's about 50 to 60% iron. It was brought down by ships, and it still is, except now it comes in like this. This is about 50 to 55% iron ore. This is about 80 to 85%, which means it burns faster, it burns cleaner, and you get a better yield on your iron with a lot less slag, which is the waste product. This is coke. You know how light that is. Coke is, as charcoal is to wood, coke is to coal. The type of coal they had in Western Pennsylvania and northern West Virginia was very conducive to the manufacture of coke, which was the fuel that they used for this. The other thing they used was limestone. Limestone was the flux. It took the impurities out of the iron ore and created something called slag. For approximately 10 tons of iron, you got about 2 to 3 tons of slag. So you can imagine how much slag was involved. These two furnaces at their peak produced about 1,000 tons a day of iron. And they ran for 72 years. So millions of tons of iron came out of these furnaces. So those are the basic 3 raw materials. This particular plant is called the Carrie Furnace Company. It was started in 1884 by 2 people called the Founds brothers, who took an old furnace from near Port Washington, Ohio. They dismantled it piece by piece, brought it here, and they blew the first furnace in 1884. It was called a merchant furnace, which meant it wasn't owned by another company. They sold the iron they produced on the open market to whoever gave them a better price. Business was extremely good in the 1880s. It was a boom time. So in 1889, they built Carrie 2, the second furnace, plus 100 beehive coke ovens. Now, a beehive coke oven, probably about 12 or 15 feet high, it looks like a beehive. And that's where they baked the coke. It took about 24 hours to make coal into coke. And they were doing that because they started something called integration. People found it was a lot cheaper to do everything on site. So it was better for them and more economical for them, made them more market competitive to have their own coke ovens here and make their own fuel. However, other mills were integrating as well. They were putting in their own blast furnaces, they were putting in their own coke ovens. So the Founds brothers had a problem in the early 1890s. The economy was down, there were huge labor problems in the valley, and they were going to go out of business because they just couldn't produce the iron competitively enough to sell to other people. So they had two choices. First choice they had was to put in steelmaking facilities. Well, the capital would have been extremely tough, especially in a down market. So the situation was they really decided not to put steelmaking facilities on this site. Now they had enough land. This land went from the Rankin Bridge over to that railroad bridge here, so there's plenty of room. They just didn't have the capital. The other thing was to sell it. Well, the steel plant next door didn't want to buy it. It was called American Wire. They didn't want to buy it. But the guy across the river who owned Homestead Works, a guy named Andrew Carnegie, his president at the time, a guy by the name of Henry Clay Frick, and we'll talk about both these gentlemen in detail as we go through the tour, bought this plant for $750,000. Size, basically the price of a house in Shadyside right now. And the Founds brothers did something very interesting with their money. Does anybody know what they did with it? Does anybody play golf? They built Oakmont Country Club. If you go into the clubhouse at Oakmont, which is where they had the U.S. Open last month, you will see a picture of the Carrie furnace. So they actually hired mules and tractors, and they built their own golf course, and now it's one of the best courses in the country. But anyway, Andrew Carnegie now has his iron, but he's got to get it across the river. Well, he's got a problem because all of a sudden he's got to cool the iron and take it over and remelt it and put it in his open iron furnaces. So the easiest way to get something across the river, of course, is to build a bridge. So he built this bridge here, which is the hot metal bridge. Had to be a very unique type of bridge because of a couple of reasons. The Monongahela River, which is here, was one of the busiest rivers in the country around 1900. There were coal barges, tugboats going up and down, and if you ever had molten iron that fell into the Monongahela River, you would get an explosion like you just wouldn't believe. The water would expand, you get a major explosion. Carnegie wasn't worried about the people who lived along the river, he was worried about it take some of his mills out. So he built a hot metal bridge in 1901, had it built by the American Bridge Company, which was owned by Andrew Carnegie, and it's very unique. First unique part is it's 5 times stronger than a normal bridge, because they were taking loads across that bridge of between 150 to 200 tons. The submarine cars were filled with the molten iron were going across there, and you'll see one of those submarine cars on the tour. So he had a tremendous amount of weight, and so you needed the bridge to be incredibly strong so it wouldn't collapse. Second thing he did is on each side of the tracks he put a 6-foot-high, 2-inch thick. All of the heights you see, makes the diameter of the air the smaller diameter carried either water or natural gas. Natural gas is the fuel they use to heat material.
Oh, really?
Try to collect everybody here. I know there's some great shots here. Yes, I've been to the top of one of these, not these ones. Too dangerous.
Yeah, there's a little bit of fun.
Okay.
Oh, I'll
want to go up there.
Well, you signed a waiver.
What is that up there?
That's actually called the shell, and inside it's called the heart. And everything was loaded from the top and worked its way down.
Okay, that's behind the material.
This is the ore yard. You can look to your right. That ore yard extended about 50 yards past where the wall is. This is the size of 2 football fields. And all this had in this ore yard was iron ore. So I want you to imagine this covered with iron ore, those little pellets you saw, all the way to the top of that railing, which is called the high line, all the way down. Now the reason they had to have so much raw material is, first of all, they were making 1,000 tons of iron a day. Of that, you're looking at 1,000 tons of iron ore a day. The lakes froze during the winter, so probably from the middle of November until sometimes the end of March, they had no source of iron ore because it all came down by lake freighter. Dropped off at Carnegie, Ohio, which is up on Lake Erie, and then was brought down here by rail. Most of the raw material came into this mill by rail rather than by barge. Main reason is the river's flowing the wrong way. The river goes this way. So you can imagine, first of all, how many rail cars there were. The iron ore was unloaded up here on this side. It came in by rail. 135 car trains came in. Originally, the iron ore was unloaded by hand because they didn't have anything automated. So you had a lot of guys here that were shoveling out cars. It would come into the car dumper, which I'll show you later, and it was brought out into the ore yard. It was dumped in a big pile, and then this particular contraption here, which is called an ore bridge, would distribute the iron ore throughout the whole ore yard. This thing, and you'll see it when you get up there, it ran on rails. It ran up and down the length of the ore yard, also with the bucket, which isn't the bucket for that particular ore bridge. They would distribute the iron ore around this particular facility, and then they would also take the iron ore and put it into the bins in the stockhouse, which we'll show you later, which is behind that wall there. And then from the stockhouse it went up the skip hoist, I'll show you that later, that went into the top of the furnace. So the iron ore came in on this side. The coke and the limestone came in on this side. This is called the high line. As you can see, there were rail tracks that came from there. The coke was put in hopper cars and it was dumped from the bottom. And the reason it was dumped from the bottom is you didn't want the coke to get crushed because it lost a lot of its good combustion properties if it was crushed. So they bring the whole line down, again, 135 rail cars. They'd unload them from the bottom. There were people that worked up on the high line. They would unload the rail cars of both the coke and the limestone, and it was put into the hopper bins along the stockhouse, which again you'll get a good look at later. I want you to imagine the scope of everything here. I think you people are going, boy, this stuff's really big.
Those are the same houses we saw over there, Dan. Yeah. There we go. This way.
This is the car dumper. This was put in 1926. It was the first car dumper put into this particular mill, and it is the oldest that's still standing. They unload the cars, the iron cars, exactly the same way today, except instead of using this system, they use hydraulic cylinders. As I said, there were 135 car trains that came in on a locomotive that looked like that, which incidentally is probably the only thing in this mill electrical that isn't owned. What happened was they bring the car in and then they unhook the car. If you can see on each end, there's a break in the tracks. They would put the car on here, they would take these, bring them down under the car, hook it on to cables and lift the whole car over that wall and dump the iron into a stationary hopper that you'll see on the other side. I had a lady here a couple of years ago from Louisiana, and she told me that's the same way they unload sugar cane down in Louisiana.
Yeah.
Today they use the same thing, except they use huge hydraulic cylinders and they eliminate all of this paraphernalia. Again, you can look at the size of this. This was the first one. There were two more that were put here as well for the other ore yards, but this is the oldest, and it's the oldest that's still standing, and it's pretty well restored. If you want to take a look around, they've cleared most of the debris. There is poison ivy around here, but most of it's been cut down. If you want to take a look at the ore bridge, you get a better view of the ore bridge from right beside it. Go ahead. Anybody wearing sandals? Okay, good. These things would come down underneath. They're underneath here, and then this whole thing would come up. This whole thing would come up, and it would come back down. Instead of taking 20 or 30 or 40 minutes.
I don't understand what you're doing out there.
Although there are cables underneath. You can see some of the cables. These places were extremely dangerous to work in because a lot of the reason was the hours these guys worked. Talk a little bit about that. These guys worked 12-hour shifts 7 days a week, 365 days of the year. They got every second Sunday off. However, the Sunday that they didn't have off, they worked a 24-hour shift. They worked from 6 in the morning Sunday to 6 in the morning Monday, 24 hours straight, went back to where they slept, and they came back at 6 o'clock on Monday evening. The 24-hour turn was called the long turn. It was in force until 1923, when the Department of Commerce forced the steel industry to go to 8-hour days, 8-hour shifts rather, because of the huge number of fatalities and accidents. In 1922, these mills killed 523 people and over 10,000 injuries. Now, if you were injured, tough. There was no workman's comp. There was no severance pay. These guys worked 365 days a year. They didn't even get Christmas or the 4th of July off because these were continuous operations. They made 14 cents an hour in around 1900 and 1910. So they made 12 bucks a week to work an average of 84 hours a week. Most of them were immigrants. Most of them came over from Eastern Europe. They were called the honkies or the bohonks. They were Slavs, they were Poles, they were Czechs, they were Romanians. So any particular ethnic group came over here, and actually they had it better over here than they did back in Eastern Europe. A lot of them just came alone and brought their own families. Tried to bring their families back later. As they became more seniority, they kind of went up the pecking order. But most of them couldn't speak English. They had to learn. If you see some of the signs around here, you're going to see them in 5 or 6 different languages. So it was a very hard way to work. I'm going to take you down now and show you the hopper. Yeah, well, that was one of the reasons that they would have to strike. When the car was young, we jumped into this particular hopper here. This had a small locomotive that was on track to be taken out into the ore yard. It would be dumped, and then it would be taken by the ore top. And what it was a top that rotated 360 degrees, and there were two bells. It was a lower bell and an upper bell. So if you were charging the furnace, the skip hoist would come up, it would distribute its charge, and because the top was rotating, it would put it evenly around the circumference of the top. The upper bell was lowered, the lower bell was opened, the material would drop into the furnace, the lower bell would be closed, the upper bell would be open, and the next charge would be redistributed around the circumference. When the material had to be loaded in the furnace, it was loaded in these bins all up and down the length. This is both the stock. We're in the stockhouse for 7 furnace right now. The one on the other side, which is closed off, was the one for 6 furnace. So each furnace had its own stockhouse. There was something in here called a Larry car. And the Larry car, with the Larry car operator, ran a small engine that went up and down these bins. These bins contain iron ore, they contain coke, and they contain limestone. The average charge was 4 parts iron to 2 parts coke to 1 part limestone. There was a Larryman helper that was in here as well that basically worked the bins by hand. See the bottom? Notches in here, he'd have a big bar, and he would actually open and close these bins. So the Larryman helper had to know a number of things. He had to know which material was in which bin. He had to know which bins were open and which bins were which bins were full and which bins were empty. And he had to make sure that these bins were constantly full with all the raw materials they needed. Remember, 2 to 3 tons of raw material every 4 to 5 minutes was going into those furnaces. So these guys during their shift were going up and down continuously for their entire shift. They never had a chance for a break because everything was continuous. It said after 1922 it was 8 hours, before that it was 12 hours. So they had to communicate to the stockyard, or the ore yard rather, that certain bins needed raw material and it would be dumped in by the ore crane bucket. So all these were filled and they were continuously being refilled all the time, continuous operations. They had little radios, actually had some sort of radio, and before that they used some sort of signal. It was a signal they put on the top of the bin. There were people that worked the high line, the people who unloaded the cars, they knew which bins were empty at the time. So there were not only people working here, there were people working up top, which as I said was called the high line. And they would know which bins had what in them. And they would actually use hand signals for people in the yards. So once they got radios, they were able to just radio back and forth. We're going to go down to the skip hoist pit, where they actually loaded the skip car and took it up to the top of the furnace. Larry car, I'm sorry. They loaded the Larry car into the skip hoist.
Was it loud here?
It was very loud here. It was also very dusty here because of all the coke dust and the iron ore dust. These were not nice places to work. Everybody's heard of black lung and coal mines. It was black lung and steel mills as well. There were also a lot of other things that we go on here too. Again, this stockhouse was down probably another 50 or 60 feet, so you only seen a portion of it. Just ran continuously. If you had to do maintenance down there, that was another problem. You'd have to have your buddy tell you when the car was coming down so you could move to the other side. If you were killed in one of these places, you were making 14 cents an hour, which is about 12 bucks a week. You could take $2.50 of that pay and you could buy life insurance. So if you were killed in here, your widow got $1,000 and you got a coffin. And what a lot of the widows used to do was buy small houses in the poor areas, which was called below the tracks and open boarding houses for steel workers that were coming over. They'd usually end up marrying one of the steel workers that came over who was single, and the whole cycle just repeated itself. But it's a wonderful view of an old blast furnace shell. The hoist house that I told you about earlier is the building on your left there with the cables coming out of it. One of the things we have on our wish list is trying to restore the hoist house as well. And that stack needs to be repaired as well. It's going to cost about $750,000.
Actually built the furnaces.
A number of different companies were contracted out. A lot of it was American Bridge, which was a Carnegie company or a J.P. Morgan company. It was, and that's how the town of Ambridge became its name, was because it's American Bridge. And the Tom Cruise movie was called Empire. Inside the shell there were panels that had grooves in them, and the water went into the grooves of the panels, and it actually cooled the fire brick. Like I said, and it was a continuous recirculating system. It would come in from the river and go out from the river. It was probably dirtier going out than when it came in. And nice and warm. Very warm.
Those are pretty big temperature variation in the water.
There was huge temperature variations in the water, which caused a lot of health problems. Around 1900, Pittsburgh had the worst incidence of typhoid and fever and cholera in the country, especially from the people who were living what they call below the tracks in the slums, because they were basically getting their drinking water from the river, and it was all being contaminated with the waste products that were coming out of the outhouses that were right next to them. So there was a lot of huge health issues here for the people who worked here. Not only working here, but also external factors as well. In fact, infant mortality rate in Pittsburgh in 1900 was about 28%. 2 out of 7 children never saw their 12th birthday. For the deer. It was built with all raw materials in the plant. They had no electricity, so anybody who has any reservations about the quality of zip ties, that thing is all mostly put together with zip ties. A lot of zip ties. And eventually she's going to fall down, so we're trying to raise money to refurbish her, to make his money, and that's how he learned to manage his business. And because railroads use so much steel, especially in the rails, he saw a future in the steel industry after the Civil War with the invention of the Bessemer converter. He originally owned some small iron foundries. In 1875, he built Edgar Thomson Works. Edgar Thomson Works is the one that's standing. It's down there in Braddock. It's the only still working steel mill that was here. He hired Edgar Thomson, who actually was his former boss at the Pennsylvania Railroad, to run it. Edgar Thomson said he'd do it, but they had to name the mill after him. Hired a brilliant engineer called Captain Jones, who basically built the mill from the start and made it the most modern steel mill around. Carnegie knew how to make money. He didn't know how much the steel sold for, but he knew how much it cost to the 10th of a cent. So he was always very, very profitable. He acquired 2 other steel mills. He acquired the Allegheny Bessemer Steel Company, which was Duquesne Works, and he did that by a little bit of chicanery. They developed a process for making rails that was actually better and cheaper than Carnegie. Carnegie told all the railroad customers, and of course he was a former railroad man, so of course they believed him, that these particular rails coming out of Duquesne Works didn't have good homogeneity, which was a made-up word. Next thing you know, every order from Duquesne Works is canceled. Carnegie goes to the owners of Duquesne Works and said, okay, you guys paid $700,000 for this. There's 14 investors. I'll just give you $50,000 cash, or you can buy shares in Carnegie Steel, and I'm a nice guy, I'll let you get out of this deal. 13 of the 14 took the money. One didn't. When Carnegie sold in 1901, that $50,000 was worth $11.8 million. So now he owns Duquesne Works, takes that awful process that had bad home ingenuity and puts it in all his mills, and his cost per ton drops $2 to $3. So now he's got Duquesne Works, he's got Edgar Thomson Works, he buys Homestead Works, which was called Allegheny Steel at the time. He bought that for cost too, because that particular mill had a union. It was more of a guild than a union. There were probably 20–25% of the workers belonged to this union, and they were former puddlers, which was a skilled ironworking job that disappeared when these furnaces came in. He didn't care. 80s were big business. He was making money hand over fist. He landed a contract for the U.S. Navy for the manufacture of armor plate when they were going to a armored Navy. So he didn't really care too much about the union because business was good, so he just lived with the union. He actually signed a contract with them in 1889, which was unique back in the area. The other thing is these guys over across the river worked 8-hour shifts. Everybody else worked 12-hour shifts. Business dropped in the 1890s. He was losing money. He wasn't losing money. He was making less money. So he had to get rid of the union. So he had a buddy, a guy named Henry Clay Frick. Anybody heard of Frick? Yeah, Henry Clay Frick was born in Westmoreland County. Again, he didn't come from a rich family. He had an uncle that owned a distillery, but he started buying up coke leases and coal leases, bought coal land. He turned out to be the coke king. He owned the largest coke plant in the area, and he was a partner with Carnegie. He eventually became the president of Carnegie Steel in 1890 with one motion: get rid of the union. He hated unions. Frick absolutely hated unions. He had no use for them at all. At that particular time, a lot of them were part anarchists. That was the anarchy movement was coming in. Again, there was a very few people who had a very large percentage of the wealth, and it wasn't coming down to the average worker. In 1892, the contract was up. First thing Frick did is he offered the union a ridiculous offer. He dropped the floor on tonnage about 20–25%. He had it prorated to a different time of the year when steel prices were historically low. These guys would have lost about 30–40% of their income. Then he decided to build a 12-foot high fence all the way around Homestead Works with a barbed wire top with only 2 ways going in and out. They called it Fort Frick. And it was heavily fortified with company security people. Next thing he did is he called a gentleman named Alan Pinkerton. At that time, the Pinkertons were a private police force. They were actually started during the Civil War, but by the late 1880s, early 1990s, they were a private police force of strikebreakers. They broke up copper strikes in Montana. They broke up silver strikes in Nevada. The International Harvester Incident, the Chicago Massacre, those were the Pinkertons. They basically brought in armed guards and the Union people disappeared. And that's how they ran the strike. The Union, on the other hand, was extremely well organized. It was run by a guy named Hugh O'Donnell, who organized the Union, and he was a smart man. He was a smart man in the fact that he knew if he got into mayhem or damage of equipment, public opinion was very important back then because everything was in newspapers and these weekly magazines like Harper's. So it had to be orderly and it had to be effective. So the idea was that Frick would bring in replacement workers, they would occupy the mill, and they would lock out the workers. Well, everybody in town knew. So what the strikers did is they barricaded the outside of Homestead Works and held it. Carnegie at the time was in Scotland visiting his roots, and he said he didn't know anything that was going on in regards to what was happening at Homestead, but he knew everything that was going on. He said it was the biggest one out of the election, and you guys in my constituency are heading to like land at the pump house, which is still standing across the river. If you ever have a chance, go over and have a look at the pump. It'll take you about 10 minutes. There's a display over there graphically showing stove. So there's a total of 6 here. The ones on this side are for number 6 furnace, the ones on this side are for number 7 furnace. The air would come in through these particular pipes from that engine house and be heated to about 1400 degrees in these stoves. One stove was constantly feeding the furnace, the other 2 were heating up air. These furnaces took approximately 110,000 cubic feet per minute of air to hold up the amount of raw material that was above them. To change them from one to the other, I had to go back and pull that chain and open that valve. He had a couple of problems. One, he had to be built like Hercules to do it, because that was like a 36-inch valve he had to open by hand. There were no actuators, or anything like that. Everything was done manually here. In here was extremely loud. I'd be screaming at the top of my lungs, and this gentleman would not hear me, so everything worked by hand signals. It was extremely dusty in here. It was extremely hot in here. And you had one other hidden danger. If you look behind you, you can see that sign in green that says gas rescue alarm. There was a lot of blast furnace gas in here. And when they had the blast furnace gas, it was approximately 26% carbon monoxide. So what you'd see is the stoveman would be sitting outside away from the gas. The man went in there, his buddy would be watching him, and he just might keel over. His buddy would take a deep breath, he'd ring that first, drag the guy out, take him outside. There were a lot of people who were gassed in here. Today, people carry CO monitors on their belt, so if a CO gets above 160 parts per million, then everybody evacuates the area. There's still certain areas in modern mills today that require you wear CO monitors at all times. The other problem, that as I said, there were a lot of gas problems. There were people who were gassed to death in here. And that was one of the worst areas in here for gas. There was blast furnace gas all over the place. Today, everybody's got face masks and monitors. When the unions came in, the first thing they didn't want was money, they wanted safety. So this is when they started redoing and trying to make these places safe. The other thing they had to do occasionally was reline these with that fire brick. So what they'd have to do was shut the stoves down. It took about 3 or 4 days to cool them. And have a crew of men who'd crawl in through there, take all the brick down, take it out, bring all new brick in, and re-brick it. It took about 2 weeks. One of our tour guides did it once. Said it was the worst job he ever had in 43 years of working in the mill. The hot air then would go into the cast house where it would go around the blast furnace, and we'll show you how the casting process works. Unmelted material would set. The material was loaded from the top of the furnace, as I said, and as it slowly dropped down into the furnace, it would gain temperature. Eventually, the coke would ignite, which would give sufficient temperature to melt the iron. The iron would then drip through blast furnace is cast. It's just the terminology used in the industry. There was a guy called a melter who would determine when the furnace would be cast. In the old days, he would actually go to the side of the furnace where there was a peephole, and he would look through with a prism to figure out how much molten iron was below the level of air. When he decided that there was enough molten iron, he would order that the furnace be cast. At that time, everybody would leave the floor and go into that building behind him. He would operate this particular machine here, which is called a tap hole drill. The tap hole drill would pivot around, would mostly run pneumatically and a little bit hydraulically. The newer ones were hydraulic. And they would actually drill a hole into that tap hole at the bottom of the furnace. Once that tap hole had been drilled, the furnace would erupt, and the first wad of iron would basically shoot up 15 feet high in the air and probably end up sometimes over the edge of that cast house. It was 2,600 degrees coming out of the furnace. Then the crew would come up. There was a crew of 5. Before safety equipment, they'd be dressed like me, except they'd have a layer of long underwear underneath their. They would wear cotton shirts, cotton pants, not metatarsal shoes like I'm wearing, regular shoes. There were occasions where clothing would spontaneously combust because of the heat. I can't describe how it would run and be guided by these dams. And you can see there's 4 different areas where the molten iron would come down. These notches were all filled with a black sand because the iron would melt the troughs. So eventually, what would happen was the iron would eventually exhaust itself. They would re-plug the hole using that machine there called a mud gun, and then the crew would come out and they would remove the iron, and that's what the iron looked like. It's pretty heavy. That weighs about 10 pounds. Take all the excess iron off, then they would dig out all of the sand, then they would re-sand this, cool it with, heat it with natural gas to get as much moisture out of it as possible. Then the system would be repeated every 3 to 4 hours. The air was injected into the bustle pipe using something called a blowpipe, which is right behind you, weighs about 220 pounds. There was a guy in the crew who would actually pick up that blowpipe in his shoulder and put it into the tweer hole. And if we go around to the side, I'll show you exactly how the tweer hole worked and how the blowpipe went into the tweer. The tweer, by the way, was a cylindrical piece of copper, pure copper, that weighed between 200 and 225 pounds. Imagine that in the scrap market.
That's the money.
The tweer would be set in here. Now this was all water cooled. These are all water lines to cool the tweer. The tweer would be inserted in here. There was a small little crane that did it, that would, on wheels that would come up. They'd insert that blowpipe inside the tweer, and then they would take this apparatus, and there was a piece that went on here that would hook onto the blowpipe, and that's how the air got into the furnace. There's 16 of these tweers around the circumference of this furnace, and that's how they did it. That was where the level of air was. Anything below this level of air was molten. Now that hearth probably went down about another 10 to 15 feet. So you can imagine how much molten iron was through there. So if you're looking at 1,000 tons of iron, this furnace did about 500 tons of iron a day. So each cask was probably 80 to 90 tons of molten iron that came down these slots. 24 hours a day, 7 days a week, 365 days of the year for 72 years. I'm going to take you around the back and show you the slag hole, and then explain to you a little bit why these places went down. Actually, the angle of the roofs are so steep because of all the graphite and the dust that were around. They wanted to get as much dust off the roof as possible. So the higher pitch it was, the faster it came down. The slag hole was actually about this big. There's actually 2 in this furnace, one here and one over there. And the guy would actually have a bar here, keep the slag hole open. The slag was less dense than the iron, so it sat on top. And the idea was the slag would run down here, run down those notch, and there'd be a slag car underneath that, which would take 10 to 11 tons of slag. Most of the slag here was run down the Mon, and it was dumped around Ravosburg or Clarton. You can still see the piles of slag there.
Century 3 Mall.
Century 3 Mall is built on slag. Those apartment buildings by the Fort Pitt Tunnel are built on slag. So there was a lot of slag. My wife lived across the river from Stelco. She could see the slag glow 24/7. So much waste material. As I said, this place lost 165,000 jobs in 10 years. It went from, I came here in 1978. I drove up the river from Clarton to Aliquippa. Every mill was booming. I moved here permanently in 1986. It was all gone. I moved here about 2 weeks after Homestead Works closed. Homestead Works was the largest steel mill in the world. All that's left now is the pump house. There's a gantry crane there, a few other odds and ends that's scattered around the mall. Plus those smokestacks you see were the stacks for number 5 Open Hearth. They never put a BOF in the Mon Valley until 1986. That's one of the reasons these places closed. This place didn't change much from 1906 to 1978. After the Second World War, the only steel industry left was in North America. The European, Asian, had all been bombed out during the Second World War. So the only source of steel was from the United States and to a smaller extent Canada. The unions were in, it was the unions' turn. So there were strikes every 3 or 4 years. Also worked on a system of what is called vertical management. It's a nice way of saying, you work for me, you do what I tell you to do, you do it the way I tell you, I don't care if you have a better way of doing it. If you don't want to do it, there's 16 other people who will. That's vertical management. One of the things I learned when I was in business, and I think it's very simple. Think about the company you are working for or did work for, and when you talk about them, do you use we or do you use they? Just a rhetorical question. Just think about it. I worked for a we company that turned into a they company, which hastened my retirement. If you use we, you feel you have a stake in it. If you use they, you feel as though you don't. U.S. Steel was definitely a they company. So there was always distrust between the union and management. All of a sudden, the companies wanted no strike contract. Guaranteed no strike. You know, everything retroactive, they put in a cost of living allowance. In the late 1960s and 70s, when inflation went up, these guys' wages went up pretty good. The other problem was the companies never modernized. The European and the Asian steel market, starting with Japan, started developing new technology.
Complaints about their buildings, the metal rooms. Never did ask for that.
Okay, so this was the gate control.
Yeah.
That thing gets moved around by hand?
No, it was on a swivel, and it was moved by hand. And they use that particular material there, which is called vermiculite. You'll see the vermiculite on the other side of the submarine car. The submarine car approach is lined by cars. The turbines created the air, which is called the wind that went through the pipes, and it went into the stoves, and from the stoves it went into the bustle pipe.
So would this take one load?
I would take one load. There'd be 4 of these located. Under each notch, there would be a submarine car. So you'd probably get 3 submarine cars in a cast.
So is that concrete on there?
No, it's called vermiculite. It's a type of heat-resistant material. What they do is they load it from the top, and then when they brought it over the river, they would.
Seen better days, huh? Have you seen some of these purple spider webs? They're just everywhere. I know, they're cool. I was trying to get a picture of one, but I couldn't get the right angle. Should I do the keys? Nope.
So the bars are brick lines.
Normally, if they plug that up, it would maintain the weight. Normally, from here to the other side would be about now. Now that's a U.S. steel because the paint period. If you look at the U.S. steel logo, it's white U.S. on a blue background.
What's with the white stuff?
Oh, we have people who come, we have artists who come in here and they put their thing out here. So obviously that those poor people who come open that valve. We have alternate, we're not supposed to comment on that. Because we're obviously not sophisticated enough to appreciate this stuff. People who did a ballet here and they left it here, and after about 2 weeks it kind of became unserviceable. I mean, this isn't the most